Hello geometry students. 4.1 and 4-2 says lesson quiz. This is not a quiz. Just a little review of 4.1. So you got to match your x coordinates up, right? So you can do 17 minus 2 squared plus 2 minus 10 squared, and we're not really going to finish this off. It's just a little reminder about how you set it up, because if you set it up right, you should be able to get it from there. So 4-2, what should you be looking for in 4-2? This is still on congruence. It's on polygons, and so the title of this is Polygons and Congruence. So what is a polygon? A polygon is a connected set of at least 3 line segments in the same plane, such that each segment intersects exactly 2 others, one at each end point. Alright, so that's why this is an example of a polygon. Okay, a set of at least 3 line segments, there's 4 in the square, in the same plane, such that each segment intersects exactly 2 others. So if we look at this, AB intersects exactly 2 other line segments here. One of them is AD, the other one's BC. One at each end point, right at the end points. Okay, so that's the definition of a polygon. That's one of the important things in this lesson. Another important thing is, how about a congruent statement? Here, this statement number 3 says that triangle ABC is congruent to triangle DEF. Congruent, it's an equal sign with a wavy line over it, meaning that if I took triangle ABC and it would coincide exactly with triangle DEF if I moved it and placed it over triangle DEF. So as a result, the congruent statement matches corresponding vertices. So I don't have a picture here, but I know that angle A corresponds to angle D, and I know that angle B corresponds to angle E because they're both listed second, because it matches up the corresponding vertices, and C and F are corresponding. So those 3 angles, it's easy to match their corresponding vertex, and not only that, but side lengths, it works the same way. For instance, AB, that side length corresponds to DE, first and second vertices, and BC corresponds to EF, second and third vertices, second and third vertices in the statement. And the other one that comes from that of the first and last one here. So you could say AC corresponds to DF, first and third. So with that in mind, angle F is congruent to angle what? Well, it's congruent to its corresponding angle. Here's angle F. What is its corresponding angle from triangle ABC? That would be C. So angle F is congruent to angle C. So this is a congruent statement, and this allows us to make these observations. And AC is congruent to, alright, where's AC? It's the first and third vertex of triangle ABC, so that would correspond to DF, because that's the first and third of the second triangle. Alright, so this is a congruent statement, and it allows you to determine what the corresponding vertices are, what the corresponding sides are. Later on in the course, when we get to similarity statements, you're going to get the same type of thing here. It always matches up in order corresponding vertices and corresponding side lengths. So you must remember that, because sometimes you're going to be asked to identify. You'll be given an angle like this instead, and they'll ask you which one is corresponding to it. And if you don't know this about correspondence statements like this, or congruent statements, I mean, if you don't know that, you'll just be guessing. So if angle F is the third one in triangle DEF, it would correspond to the third one in triangle ABC and therefore be congruent to it. Alright, same thing with the side lengths. Alright, write out the corollary to the definition of congruent triangles. Two triangles congruent to a third triangle are congruent to each other. So let's say I've got this triangle is congruent to triangle 2 here, and if I have triangle 3 here, that's also congruent to triangle 2. So two triangles congruent to a third triangle are congruent to each other. So which two are we talking about here? Okay, two triangles congruent to a third triangle. Triangle 1 and triangle 3 are congruent to triangle 2. Because they're both congruent to the same triangle, they have to be congruent to each other. So in this case, we could say triangle 1 is also congruent to triangle 3. That's the main event here for lesson 4-2. Alright, let's have a geometric homework session here.